Diving back in Houdini, we're going to create a very simple HDA, a stone fence HDA. Another subnet. We will give this subnet a line as input, so just a curve over here. The curve will be generated in Unreal, so we won't have to add it. Let's just draw out some splines. Added some control points. And this asset will have the input, the curve as input, and it will have a data table as input. And for now, we're just going to give it a height. So let's add those sliders. So height. We'll limit it to 1 meter min, and that doesn't really matter. Let's set it there. Default value is going to be 2. Alright, then we need to place an object merge inside. This is where we're going to fetch our data table. So let's go into the node, from node, object merge, and number of objects. Add this. Right now we can add n objects to this. Alright. I actually don't want this to be n objects. Let's change this a little bit. Let's do this a little bit different. Let's just do an operator path for now. Let's call this data table. Very simple. It's going to be our initial setup. Object goes over there. And before we continue this, we will save this as an HDA. Create digital assets. That's over here. Access. And we don't really actually care too much about all this stuff. It's just set it up however you want to set it up. And over here is also fine for now. Let's do this actually in this location. It's our hip folder. Folder HDA. The name is going to be stone. Yeah. There we go. Let's create this. Now we have our HDA, and this HDA can be loaded in Unreal. Right now we don't really do anything yet, which is fine. So as it is. Share. I'm going to close this Houdini file for now. So save this and I'll close this Houdini file. So, and the reason I do this is because I'm going to keep editing this HDA with a live session from Houdini, which is the way I like to work. So yeah, I'm closing this HDA and then we will continue in Unreal. Let's add our HDA to the Unreal scene. Just dragging it in here. Save this and let's throw it in the Houdini logo as we are having an empty HDA. Basically, for the data table, we can just immediately throw this in there. For the geometry input, let's change this to curve. I can see we have our curve. By alt dragging, I can have more points. And for now, one more point. All right. Now we have a basic input for the height, and this one is set to 2. Let's just keep it over there. And this should be fine for now. Let's open the Houdini session sync. So we basically have Houdini open, which is immediately also being used in Unreal, which is very helpful. Here, side, we can see all our stuff has appeared. We basically only care about this thing. It has a bit of an offset, but that doesn't really matter that much. Right now we can see we have our data table. Let's open up geometry spreadsheet again. And we can see that we have all the information we need. Now we're going to set up a couple of tricks which are kind of important to have. So let's say we would resample this. Let's say that the resample set to a length of 1. We will set it to be a subdivision curves. And then we are going to do tricks. Over here we are going to do extract centroid. And what did we care about again? Well, we first actually want to use those bounding boxes, right? So we will do a for loop for each point. We will have our initial box. Oh, not the box. The box. Then we will have a null node. That null node we are going to call out attributes. That's where we're going to fetch our information. Right now, this is our bounding box, which is Unreal Data Table 3 bounding box. That's how everything will be named. Now we're going to fetch something from point. It's a string attribute. It's attributes. It is the point number 0. And then we have Unreal Data Table number 3 and bounding box. And that should be it. And we care about number 0. And this is actually not a string attribute. So let's go at point. There we go. And that seems about right. And we will do the same for the other two. Right. Now we have our box containing the correct information. Doing this for each loop. Let's hide those other objects so we can see our box. And I have something in my screen somewhere. Let me just quickly view. There we go, that's better. There's other objects as well. What's going on right here? Let's do it again. Let's go over here. So we have our box. Our different boxes, which are the bounding box information of the thing we need. Now we also want to have some more information. So what we want is the name of these things. Having a name attribute. And we are going to be having a Unreal Instance attribute, because that's what Unreal uses. Name attribute is a string. The string value, we're going to get it relatively similar. This time it's a string that we're grabbing, so we also don't need its index. And we know that number 1 was name. And then we do the same thing for Unreal Instance. String. This is going to be path. I believe this was number 2. Double check. Unreal Data Table name, that's correct, and path. And let's make sure we're evaluating this. There we go. Some stones. Correct names and everything. Alright. Now, first step, which is handy to have. We have a point cloud also from this, because right now we have a bunch of boxes, but I also want this to be a point cloud. We're going to do an extract centroid. And let's see, are we missing run over primitives, pieces, name, correct? Are we right now where we're setting these? Point, let's do this primitive. Perfect, we got a bunch of points located at 0, 0. And these points have the correct name, and I also want them to have Unreal Engine there. Right now, if we would do a attribute copy, this is the first thing which is cool, because if we would be using a resample, or even if we would be using a scatter node to scatter on top of, let's say, a grid, or even on a spline, both those methods are equally valid. We just have a bunch of points basically. What we can do right now is to wire in the points, and we can copy the name, and we can do a sort to make sure it's random. And right now, if I would visualize those names, let me add a visualizer for the names called name, and the attribute is also name. Now we can see that we have our random stones being assigned, which is perfectly. And right now this is done not completely random, because it basically tries to assign randomly stone 0, then 1, then 2, then 4, then 0, then 1, then 2, then 4. So you will have a even distribution, kind of. And for stones, that's perfectly fine. You could, of course, do it in a different way, where you beforehand look at everything that's possible and then do it by chance. Many different approaches are possible. And we're using this for now. And this is nice because you can use any point cloud as input, basically. Cool. So we have our stones. Now, this is something like you could already, if this is your final thing, you could already also copy over the Unreal instance and be done. Here is something that I want to show you, which is kind of neat. Is if we do first a copy to points. I'm first going to copy geometry on top of stuff, attribute mode. So now I need it to be on the points, actually, these attributes. Oh, primitive. I need you to be on the points. Right now, I'm copying over. Actually, don't need it to be there. I still want to keep them. All right. Right now, I can use the piece attribute name. Look at these stones, and now you see that only the correct stone is being placed on the correct point, because we're matching them with their piece attribute. It's kind of neat. Now we're going to create a custom subnetwork, which is going to basically redo what we've done over here, but again, some reasons for it. We're going to need 2 inputs. One is our actual assets. Let me do this again. And then we are going to do a each connect piece. We know the primitive order of these is all the same. Basically, I want to extract the centroid from these two. All these are separate stones. And what I want to do is to use a blast. I'm very easily going to grab the normal and the up vector. For the normal, I think I need number 0, so let's check. Yes, that's the normal that I want, so we're just going to keep that primitive. And we're doing the same for the top, which is over here, number 1. 2, there we go. And then if we make sure that those have primitive normals, set this to primitive. And now we can transfer this to our point over here. Because we're doing points and primitives, I'm just going to use a point triangle. So let's set the up vector. Up equals prim second input value and number 0. Set up value. We're going to do the same for the normal. And wire this in and wire this one in. And this is going to be the normal system. Actually, I should be fetching the normal in both cases, but I'm setting the up value, of course. And over here, I'm setting the normal. There we go. And let's visualize that vector as well. There we go. We can see the up vector. See the normal if that one is larger as well. Normal, guides, scale normal. Right now, normal. Correctly, they're now overlapping. And now they're rotated. All right, let's in there. And see, so this is right now. I messed up a little bit. Let me rewire this again. This one should be the normal. Other one should be the up. This one has its normal set correctly. So perfect. There we go. Now we have our normal set, and we can continue from here. For everything. Probably don't have to do this in a for loop, but it's easy to set it up like this. Take off the tutorial. Right now, let me also save this right now. Because that's the way we can just keep on adding this asset, which is very nice. And from here on, we still need to be a Unreal instance, and I need the attribute copy node for that. Second input, both points, and I'm gonna match it by name. I believe I still have a name attribute on all of these points. Yes. And I'm going to fetch Unreal instance. So right now we should have a instance attribute if input was set up correctly. And we're missing it over here. Let's make sure it's over there as well. It then also needs to be on points. We can actually see it. Perfect. So there it is. We now wire this into the output. Again, we go back into Unreal. You can now see that we are instancing these stones. These stones are fetched from a data table, so we're not exporting, importing all these huge nanite meshes all the time, which is very efficient. We basically just care about the bounding boxes for now, or systems setup only care about the bounding boxes. And this is just a huge workflow improvement in a lot of cases, because we don't have to deal with, let's say, 20 different types of stones, all high detail nanite meshes, trying to get them into Houdini. And whenever you have to reload your HDA, you have this whole heavy process having to redo that basically. Now everything is safely stored inside of Unreal. You can easily also regenerate all the stones, no manual clicking. You have all those stones separately being inputted into the system. This is definitely an improvement over that. All right. Let's place down a sweep. This sweep, we're going to connect this to our example. Place a line. Right, and then I want this line to have the same height as our height input. A little bit variable. And then from here on, I'm going to do a scatter first. Scatter, let's make it a little bit normal. Maybe even density instead of count. It doesn't matter what size our fence is. And go over there. And we have those two steps again. Right now I'm still missing normal. Let's make sure that we have our normal. Perfect. And I don't point triangle. Up. There we go. Alright, that's all fine. From here on, we can do just a quick simulation step. So we're going to do a RBD bullet solver. I'm going to do based on connectivity. Set this to be a string. Don't forget to set it as a string. Class. It needs to be primitive as well. And then a back. Something that RBD symbol likes. And the name attribute is now class, which has to be a string attribute. I think at least it works. Now we have our back doing its stuff. Throw this in. I still kind of want this to be guided a little bit. So if we go back to our, not you, if we go back to our initial sweep. Let's do another sweep, or yeah, let's do another sweep. Which doesn't have a line, but it has a... Let's actually use a grid over here, and this grid needs to have the same height. Line is straight up. Smaller, if something like, oh no, wait, right now. This one needs to be there. Maybe even 0.5. I'm going to do a convert line. And I will blast 2. Now we kind of make the shape we want our sweep to have. Perfect. Transform up a little bit by this. All right. Fully extrude. Per individual element. Oh, of course, after sweep. And now, well, reverse. We have a shell. Perfect. Save again. Be sure. Now we have a shell for our Put sim vision. Now they're still connected a bit too much. Let's see if we have this one correctly as well. Looks healthy. Vision, are you in the right spot? Maybe make this wider to right back. Alright, so in the bullet solver, of course, set it to concave. It was a convex hull, and that of course doesn't work. Right now, you can already see it kind of doing its stuff. Let's change up these settings again a little bit. Increase this size. Let's do this to 4. Do this scatter to be. I also moved it down a little bit more. Do that also a little bit more. See if I can extend this, or maybe let's just do a little points for now. See what happens if we put this in here. Separate them out enough. Already we're getting quite some cool results. So for now, like, yeah, for you, just play around with it. I want to show mainly is if we now unpack this, because we set up the this other system, we have already a pretty cool system, which should already work in Unreal right now. Perfect. This way, it's very, you can do some very cool and quick placement, and doing a lot of very high detail asset placement without breaking Houdini or Unreal and still keeping it stable. So that was it for this video. I hope you enjoyed it.